Good morning, students. In this lecture, I am going to discuss a new chapter, students. Write down Fourier Transform. What, students? Fourier Transform. Fourier Transform. In this lecture, I am going to discuss Fourier Integral Theorem. What, students? Fourier Integral Theorem, Fourier Sine Integral and Fourier Cosine Integral. What, students? Fourier Cosine Integral. Now, before going to the Fourier Integral Theorem, I want to discuss the basics, students. What, students? Basics. Now, what is the meaning of transform, students? Transform. In mathematical device, transform means it converts one function to another function, students. We observe in Laplace transform, students. Observe Laplace transform. The use of the Laplace transform is we are finding the solution of ordinary differential equation. What, students? What is the use of Laplace transform? We are finding the solution of ordinary differential equation. Now, this is Fourier transform, students. Fourier transform is finding solution of partial differential equation with boundary condition. What, students? With boundary condition. This is the use of the Fourier transform, students. Now, the concept is here, students. Fourier transform. Now, see, students, this is, observe this term. This is Fourier. What, students? Fourier. You learn Fourier series, students. You learn Fourier series. What is Fourier series, students? There is a periodic function. Okay, periodic function. We can f of x in the interval, say minus c to c. We can express as a Fourier series, students. We can express as a Fourier series. Now, this Fourier series, we are extending, students. What, students? We are extending the Fourier series. Periodic to non-periodic. What, students? Periodic to non-periodic. And the interval is here minus infinity to infinity. What, students? Minus infinity to infinity. Here we can express as Fourier integral. What, students? Fourier integral. Now, once again, students, the Fourier transform is extension of Fourier series. Fourier series, students. Now, before going to the Fourier integral, we need some basic definition, students. Some basic definition. Let us see. Integral transform. What, students? Integral transform. What is first letter, students, here? I. So, I of f of x, that is equal to I of f of x, that is equal to, say, integral a to b f of x k s x dx. What, students? Integral transform definition, I of f of x, that is equal to integral a to b f of x k of s comma x dx. K of s comma x dx. Now, here k s x is called, k of x is called kernel of transformation. What, students? Kernel of transform. Kernel of transform. Now, if k of s comma x, that is equal to e power minus sx. What, students? E power minus sx. It will become Laplace transform, students. Laplace transform. You already learned, students. L of f of x, that is equal to, what is definition, students? Integral 0 to infinity f of x e power minus sx dx. E power minus sx dx. Now, in place of kernel, if k of sx is equal to if I write e power isx, what students? E power isx, it will becomes Fourier transform, students. Fourier transform. It is defined as f of fx, that is equal to, this time here, integral minus infinity infinity. What are the limits, students? Minus infinity to infinity. F of x e power isx dx. E power isx dx. This is the definition of Fourier transform, students. That means, what is the origin, students? What is the origin? Integral transform. Integral transform. In integral transform, in the place of kernel, if I write e power minus isx, we get Laplace transform. If I write e power isx, we get Fourier transform. Fourier transform. Now, let us see the statement of Fourier integral theorem. Right on, students? Fourier integral theorem. Fourier integral theorem. This is the statement, students. F of x, that is equal to 1 by pi integral 0 to infinity, integral minus infinity to infinity, f of t cos lambda of t minus x dt d lambda. dt d lambda. You have to prove this one, students. To prove this statement, we are using the concept of Fourier series. What, students? Fourier series. Right now, students, proof. The Fourier series of f of x, the Fourier series of f of x in the interval minus c comma c is what is Fourier series, students? What is Fourier series? Very good. F of x, that is equal to a naught by 2 plus sigma n is equal to 1 to infinity an cos n pi x by c, students. N pi x by c plus sigma n is equal to 1 to infinity bn sine n pi x by c. N pi x by c. Now, what is a naught, students? What is a naught? 1 by c integral minus c to c. Previously, right here f of x, students. I want to change the variable here. Say t. Okay, students, t. So f of t dt. F of t dt. Now, what is an, students? An 1 by c integral minus c to c f of t. Come on, tell me here, students. Cos n pi, very good, t by c. N pi t by c. Now bn, students, bn 1 by c integral minus c to c f of t sine n pi, very good, t by c. T by c. So this is 1, students. The Fourier series of f of x is say this is 1. Now you substitute a naught, an, bn values in 1, students. In 1 we get come on, tell me, students. F of x, that is equal to a naught by 2, students. A naught value 1 by c. So 1 by c, we already have 2, students. So 2c integral minus c to c f of t dt. F of t dt plus an value, students. So 1 by c integral minus c to c f of t, this one, students. So 1 by c is constant. So right outside the integration, integral minus c to c summation n is equal to 1 to infinity an value, students. An value. What is an value? F of t cos n pi t by c, students. N pi t by c into cos n pi x by c. N pi x by c into, students, into into here it is dt students, it is dt, here also it is dt, so dt plus bn value students, 1 by c integral minus c to c f of t sin n pi t by c into dt. So 1 by c integral minus c to c bn value students, bn value. So summation n is equal to 1 to infinity f of t sin n pi t by c into sin n pi x by c sin n pi x by c into dt. Now that is equal to 1 by 2c integral minus c to c f of t dt plus c students, you can take in common 1 by c and then c students integral minus c to c and summation also students, summation sigma n is equal to 1 to infinity and f of t students, f of t into write down the rest of the terms students. What are the rest of the terms here? Cos n pi t by c into cos n pi x by c. I want to write a dt in the last students. So plus here also you can take down 1 by c integral minus infinity minus c to c sigma n is equal to 1 to infinity. Okay, right. F of t also comes students. So we get here sin n pi t by c into sin n pi x by c into dt. Now see students, it's like cos a cos b plus sin a sin b. We have formula students, cos a cos b plus sin a sin b. What is formula students? Cos a minus b. What students? Cos a minus b. So that is equal to 1 by 2c integral minus c to c f of t dt plus 1 by c integral minus c to c sigma n is equal to 1 to infinity f of t. This can be written as students cos a minus b. What is a students? N pi t by c, b n pi x by c. So here also I can take common n pi by c students, n pi by c. So what are the rest terms? t minus x into dt. So this is 2 students, this is 2, this is f of x. Now let c tends to infinity students. What students? C tends to infinity in the first term of 2 students. So when c tends to infinity here, c students here 1 by 2c integral minus c to c f of t dt. So whenever c tends to infinity here, this value is finite students. We are assuming this f of t is convergence. What students? It is convergence. So it is finite. Convergence means it is finite. So it is finite. C tends to infinity students. 1 by infinity. 1 by infinity means it is 0. 0 into something, the value is 0. Now I want to substitute c tends to infinity here students. Before substituting c, I want to substitution students. Let us see. See students, put here students del lambda that is equal to pi by c students. I want to take pi by c as del lambda. That implies I have 1 by c students here, 1 by c. So 1 by c is equal to del lambda by pi. Del lambda by pi. Now, whenever c tends to infinity, what about del lambda value students? Del lambda value tends to 0 because 1 by infinity value is 0. So, del lambda tends to 0. Del lambda tends to 0. So, the second term becomes second term 1 by c integral minus c to c sigma n is equal to 1 to infinity f of t cos t minus x pi by c means students, pi by c means del lambda into n into dt. I want to substitute 1 by c value, students. 1 by c value is del lambda by pi. So this is say 1 by pi into del lambda. Now I have a result, students. We have a result. So what is result, students? Limit del lambda tends to 0 sigma n is equal to 1 to infinity f of n del lambda into del lambda. Or students, limit del lambda tends to 0 sigma n is equal to 1 to infinity f of n del lambda into del lambda. That is equal to, it can be written as integral 0 to infinity f of lambda into d lambda. So this is equal, this can be written as, students, 1 by pi when we are substituting c tends to infinity, students, and del lambda tends to 0. So del lambda tends to 0 here, students. Now this is f of n comma n del lambda into del lambda, students. So it can be written as integral 0 to infinity. Now see, students, c tends to infinity and del lambda tends to 0, students. C tends to infinity means here integral minus infinity to infinity. F of t. See, students, here cos t minus x into, see, students, here f of n del lambda, it can be written as, students, f of lambda. So cos of t minus x del lambda into n, it can be written as lambda into dt and d lambda. This is, so this value when c tends to infinity, first term value is 0, students, and we get this one. So this value is equal, students, f of x. So this is the Fourier integral theorem. Let us see Fourier sine integral and Fourier cosine integral, students. Fourier cosine integral and sine integral. Now f of x, that is equal to 1 by pi integral 0 to infinity integral minus infinity to infinity f of t. I want to write cos a minus b formula, students. Cos a minus b. What is cos a minus b formula, students? Cos a cos b plus sin a sin b. So f of t into cos a is, students, t lambda. So t lambda cos lambda x plus sin t lambda sin lambda x into dt d lambda. Now that is equal to, you apply double integration on both terms, students. So we get here 1 by pi integral 0 to infinity, integral minus infinity to infinity, f of t cos t lambda cos lambda x into dt d lambda plus integral 1 by pi integral 0 to infinity, integral minus infinity to infinity, f of t sin lambda t sin lambda x dt d lambda dt d lambda. Now if f of x is even, students, f of x is even. Now f of t is even, students, cos t lambda also even. Even into even we get even, students. Even into even we get even. Now here, students, here this is even, this is odd. Sin lambda t we know odd. So even into odd we know odd. So value is, this value is 0, students. This value is 0. So we get here f of x that is equal to, since it is even, we have one formula, students. So what is the formula? Integral minus a to a f of x dx that is equal to 2 into integral 0 to a f of x dx if f of x is even, students. F of x is even. So this can be written as 2 into integral 0 to infinity. So 2 by pi integral 0 to infinity, integral 0 to infinity f of t, come tell me, students, cos lambda t cos lambda x dt d lambda dt d lambda. This is called Fourier. Come on, guess, students, we have cosine terms. So Fourier cosine integral. Fourier cosine integral. Now if f of x is odd, f of x is odd, students. So whenever it is odd, cos is even, so odd into even odd, so the value becomes here 0. Here, students, odd into odd, so we get here even, so we get this value, students. Again apply the same formula. We get here f of x that is equal to 2 by pi integral 0 to infinity, integral 0 to infinity, come on, tell me, students, f of t sin lambda t sin lambda x dt d lambda dt d lambda. See, students, here we have sine terms. So it is called Fourier sine integral. Once again, students, what is Fourier integral? F of x that is equal to 1 by pi integral 0 to infinity, integral minus infinity to infinity, f of t cos lambda of t minus x into lambda dt d lambda. From this Fourier integral we get Fourier cosine integral and Fourier sine integral, students. How can you get Fourier sine and cosine integral, students? By taking even and odd. Whenever it is even, we get Fourier cosine integral. Whenever it is odd, we get sine integral. Hope you understand, students. Thank you for watching this video. Jai Hind.